Hey, good morning, everyone, and welcome to the session. So this is part of the series of interview questions that we are conducting, and this is more like to enable you people to prepare for your interviews. Okay, in the previous session, we've worked on the statistical analysis related questions, descriptive statistics, then confidence intervals, data visualizations, EDA, CRISP to DM related questions, right? So that was covered as part of our previous session that was conducted last weekend. You can go through the YouTube link. It will be shared. It is already been shared with you people. You can check in your LMS recommended videos also. Now, in today's session, we will be starting off discussing about the data mining concepts. Okay, we will start with the fourth module. Of course, I'll also be touch basing the questions from the third module of CRISP DM. Now, before I start, I want to check how many of you have not connected with me on LinkedIn and Facebook. All the social media channels, right? You have to basically be connecting with the trainers, your trainers. If you are not connected, connect immediately. This is to make sure your profile is getting the relevant content that we keep sharing. Okay, that's very important. The latest of the informations, the programs, these kind of sessions, all these things will be shared on the social media channels. Not just this page, you also have to connect with 360 Digit MG LinkedIn page. So there will be very interesting content that will be published. We are conducting a lot of interview related questions. So you need to connect to this. If not, do connect immediately. It's very, very important. All right. So I've shared the link here. Okay. And there are quiz competitions that are being conducted. Right. And informative content would be there. Look at this. Fun kind of puzzles. So it's fun while you're learning also. So do connect with us on LinkedIn and social media, okay? All the social media channels. All right. So that's about strengthening your social media profile. Remember, recruiters are looking at your social media channels. That is the most important web page, or that is the most important profile that recruiters look at. Because if I take your CV, resume, you might be writing anything. You might say you have 10 years of experience into analytics and you are a chief data scientist. How do I authenticate it? How do I authenticate it? Yeah. Now, as a recruiter, I look at LinkedIn profile. Now, on LinkedIn, you cannot lie. Isn't it? You cannot lie on the social media page. Everybody is looking at you, right? All your known connections will also be staring at you. So you cannot lie there. So that is the source of truth for me. So how do you keep that source of truth relevant to your current profile as well as the upcoming profile that you are going to target? You have to start posting relevant content. You need to have connections which are in this stream. Right? So I keep pushing people to have the social media links or the social media channels strong. And you have to spend every day 15 minutes minimum on your social media profile to make it very, very live. Okay? So start doing that. If you have not done that, I expect everyone to do this. This is my profile and this is 360 Digit MG profile. Right. I see a lot of people still joining in. All right. Not just this LinkedIn, guys, all the other social media channels, as I said, you have to explore and connect. Okay, that is the value add you will have. Trust me, it will be the primary source of truth for the recruiters. Next, where is my, yeah, I'll pull this up. So let's start with the interview questions. Okay, imagine I am the interviewer here and you are sitting in front of me for taking your interview, right? Because so many people are there. Let me not talk about individual profiles. I'll be asking questions related to the subject directly. All right. So let's jump in. I'll be repeating few questions, of course, from the previous session. And at the same time, I'm recording these questions, and these questions would be there in our learning resources on the website. Okay, they will be getting uploaded there so that in future also you can refer to them. Now let me start. How many stages does CRISP DM have? Very good. Can you tell me what all steps we do in stage 3 of CRISP DM? Okay, let me try and increase the font size. Yes. Very good. Very good. So how many steps does CRISP DM have? You already answered 6 steps. In stage 3 of CRISP DM, what are the primary steps? That are performed. So here we do EDA, data pre-processing or data cleansing, or you can call it as data organizing. Along with that, you will do exploratory data analysis. Along with that, you will also do feature engineering. Next question. Oh, sorry. Huh? Yeah. What are the 2 broad machine learning concepts under data mining? Very good. The 2 broad approaches are supervised and unsupervised learning. There are other approaches also, transfer learning, reinforcement learning, semi-supervised learning, but broadly under data mining, we have 2 techniques, supervised technique and unsupervised technique. Why is supervised learning called as supervised? Very good. Very good. Very good. So data mining concepts basically train our machines to capture the insights or capture the pattern in the data. And when you are training your machine with this historical data, if you are telling the machine that, hey, if this is the set of data, right? If I have, oops, not sure why is it not good. Yeah. if you have a set of input variables, then the pattern in this can be identified under the supervision of Y. Right? Hence it's called as supervised learning. So your training is happening with the knowledge of output variable or labeled data. Very good. What are the two approaches that we have for getting this base equation? No. Very good, Azharuddin. That's correct. So y is equals to f of x is the base equation. What does it say? For your supervised learning techniques, you're basically saying try and get the relation between x and y. Yeah? You're getting the relation between x and y. How do you define that relationship? Mathematically, you have to express that, right? If you have to express that mathematically, then you need to understand the function which can be defined or which can be used to define the relationship between y and x. Where y is a single output variable, which is also known as dependent variable, where that capital X, which are the statistical equations which are already defined to be used. So we take that statistical equation, a mathematical equation, and then we try to define the relation between y and x. Right? So that's your base equation example. And when we say black box techniques, the mathematical expression is found by your machine itself. But we'll not be able to explain that equation. We'll not be able to explain the equation. That would be the challenge. Next question. How do you evaluate an unsupervised learning technique? Yeah. I'm jumping here and there just to make, oops. Yeah. So how do you evaluate an unsupervised learning technique output? There's no dependent variable, guys. Come on, unsupervised we are talking about here. No. Okay, clustering is just one technique of unsupervised learning techniques. Now we have to evaluate Okay, let me park this question to you all for later time. Let me record another question. What all unsupervised techniques can you name? Yeah. You have to refer to mind map. It would be easy for you to refer to the mind map. Under data mining, we are talking about machine learning. You have supervised and unsupervised learning. If I open my unsupervised learning, you can see there are a bunch of techniques which are recorded here, which are posted here. So we have clustering, we have dimension reduction, or it is also known as factor analysis or feature analysis. You have association roots, or it is also known as market basket analysis or relationship mining. We have recommendation system or collaborative filtering. We can also call it as personalized strategies. Then we have network analytics. Text data, of course, is had to be treated in a different way altogether. In text mining, you also have supervised and unsupervised. Both will be part of the text mining. All right. So these are the different techniques that are available under unsupervised learning technique. Okay. Next. Can I have overlapping, or let's say properties of clusters? What are the properties of clusters? Yeah. Mm-hmm. Okay. Distance metrics, similar properties. Okay. So clustering techniques basically are talking about non-overlapping clusters, which basically means records which are dissimilar, excuse me, records which are dissimilar, they should be placed in a different clusters, right? And when you have dissimilar, when you have multiple clusters, each cluster should be different from the other, right? So simple properties of the clustering techniques that we are talking about, the grouping techniques that we are talking about. Look at clusters which are disjoint. We say basically we call it as disjoint clusters, non-overlapping clusters. Yeah. We may also have overlapping clusters. Yeah. So you basically have to deal with overlapping clusters as well. LDA is one of the techniques that we can apply for getting these overlapping clusters. We do have neo k-means. K-means also can be used, of course. Yeah, non-exhaustive, non-overlapping. There will be different techniques that you can try and explore. That's about properties of clustering. Whenever we talk about hierarchical clustering or k-means clustering that you learned, these clusters will always have to be disjoint. Okay? Right. We also have agglomerative or divisive methods. Right? Okay, let me ask you a question on okay, my data have outliers. Okay, let me write this. Data with outliers. What technique will be appropriate for clustering? Yeah. Yes. K-means would get affected, right? K-medians would be appropriate technique. Yeah, K-medians will be appropriate technique. Right. Or K-modes can be applied, guys. We're talking about clustering. We're not talking about outlier treatment here. Remember? We're not speaking about outlier treatment. Right? Yeah. So K-medians or K-medioids. Yes, DB scan can be there. Then you can also use optics as well. And there are various other techniques that you can apply when you have outliers in your data, but K-medians basically is something that we readily choose. Right. What is the primary difference between hierarchical clustering and non-hierarchical clustering? Yeah, what is the primary difference between hierarchical clustering and non-hierarchical clustering? Very good. Wonderful. Number of clusters is known. Okay, good. All right, so let me. In hierarchical clustering, we go with a natural flow. The grouping happens, the hierarchy is created first. And we do not know what is the cluster number or what is the cluster size, right? K value is not known upfront. And here we will have a dendrogram which will visualize or which will summarize the entire clustering process or the hierarchy. And based on this hierarchy information, we split the data into K clusters. Whereas in K-means clustering, we do not have dendrogram, and we will upfront know what is the K value. Another primary difference between hierarchical and non-hierarchical clustering are that the number of, or I should say the storage and the computation burden, right? The number of distance calculations that we do on hierarchical clustering would be very huge compared to non-hierarchical clustering. And storage space also is more. It requires, hierarchical clustering requires more because you have to store n square distance matrices at every stage of splitting. So that's about the difference between hierarchical clustering and non-hierarchical clustering. How do I find the best value of K? Very good. Very good, very good. Okay, identify the best value of K for clusters. The best value of K, which is the number of clusters, can be identified by using a rule of thumb formula, which is square root of n by 2. Right? That's the thumb rule, which was used initially in old days, previously, or historically. But that thumb rule, square root of n by 2, that formula is getting affected by the number of records that we are trying to group, which should not be an ideal case. Right? So we are getting away from that formula and we are using more appropriate statistically valid equation or valid condition, which is looking into the total sum of squares within the clusters. It's a statistical measure, right? And we use these total within sum of squares for different K values. And we choose the K which gives us the least within sum of squares. And this entire process is interpreted by using elbow curve or scree plot. Right? Elbow curve or scree plot. Next. Let me think of a question here, okay? A lot of people still coming in. What should I do? What technique should I apply to measure the similarities between the records? if the data is categorical. Yeah. Okay. Come on, guys. Very good, Anuj. But that is not the exact answer. Very simple, guys. Very simple. We are talking about categorical data. I'm not talking about binary. If I have categorical data, then we assign value 0 for the distances when we have the similar records or the similar categories for the records. Or we put distance is equals to 1 if the categories are different. Yeah. There's another technique that we can apply, which is Grover's general dissimilarity rule. Grover's general dissimilarity rule. That is also something that we apply. Yeah, so the answers that you are giving are distance calculations. You are basically giving me the options that we apply for binary data. If I have let's say mixed data. Okay, let me ask this. If I have mixed data, then what distance techniques can I apply? Yeah. Very good. Yeah, my question was a little tricky. Okay, the answer is any of the distance metrics, any of the distance calculations can be applied. But in order to use them, we need to put the non-numeric data onto the numeric lines. So if I have mixed data, first you can normalize the data to bring the scale of the data to dummy variables, that is 1 and 0. Then you can apply dummy or one-hot encoding method onto your non-numeric data. You're talking about mixed data, right? So we need to do that. And once everything is on the numeric scale, we simply apply any of the distance metric Euclidean distance or Manhattan distance or correlation based distance, or any of the distances can be applied. Or yes, Gover's general dissimilarity rule can also be applied. Okay. Let me again. There's so many questions. What happens if I use standardization, and what happens if I use normalization? Will my clusters be same if I use standardization techniques and normalization techniques on the original data? Will my clusters be same? Yeah. Okay. Okay, how many of you have actually tried this? The answer is no, the clusters may change. The clusters will not be same. Read the question, guys, read the questions properly. When you're using standardization, your numeric values will be different when compared to the technique that you're applying for normalizing, min-max normalization, right? So min-max scaling will give you the data which is in a range of 0 to 1. Magnitude-wise, the values will be different when compared to your standardization technique. Now, if your values are different, numerically the magnitude is different, then obviously when you are measuring the distances between these records, pairwise records, the distance measures will get affected. So the end clusters might change. K-means clustering gives, okay, is the K-means clustering output same every time we execute? On the same data you're applying, is your K-means clustering output same? No, right? Absolutely. K-means clustering, the initial partitions will be different, hence the final result will also vary, because it is trying to minimize the within clusters variation. Using within sum of squares, it is trying to minimize the variation within a cluster, and it reaches to local minima for every execution. It will reach to a local minima. What is the K-means clustering also known as? Okay, I'll rephrase this. K-means clustering gives different results for every execution. So it is also known as, because of this particular feature, it is also known as okay, not non-hierarchical. For this property, specifically for this property, what is it called as? No, there's a word. No, no. Non-deterministic. It is also known as non-deterministic clustering technique, because the final result is not same. Non-deterministic, remember that. Okay, next. Why is clustering useful? Or in what ways it is useful? Let's see. Minimizing the rows? No, not really. That's not the appropriate answer. But what is the advantage of that? Rakesh is using the right word. Homogeneity. Clustering technique brings out homogeneous pairs of data. When I say homogeneous pairs of data, this particular data, these records will have low variance or zero variance or close to zero variance. That means the information you extract would be obvious. You can easily infer information out of the homogeneous group of observations. Clustering is also applied as dash technique for your CRISP-DM methodology. In CRISP-DM methodology or in your data analysis, clustering is also used as dash method. Can anyone think of this answer? Feature selection, not really, no. EDA, very good. Descriptive statistics, descriptive analytics, right? So it is also used as an EDA technique, which basically explains the data better. Next. What is the main application, or what are the advantages or application of PCA? Why would we use PCA? Very good. The application of PCA is to minimize the high dimensional data. Feature engineering. Right? We are doing feature engineering. We are reducing the high number of features. What are the benefits of PCA? What are the benefits of PCA? Very good, very good, very good. Benefits of PCA are reducing the complexity of your computation. Reduce the number of columns to reduce the computational complexity. And the primary benefit is to achieve performance. You will be able to do the prediction much faster. The another benefit is visualizing the data. A multivariate data can be visualized in PCA. Okay, Pallavi has a question. What is PCA? What are other techniques of dimension reduction? Yeah. Only SVD? Oh, okay. Very good. LDA, SVD. These are all used for dimension reduction. Of course, backward elimination. Data cube aggregation. Feature subset selection. Very good. Very good. Very good, guys. Very good. Lasso, yes. So many different techniques are there, right? So many different techniques are available. We don't have to restrict ourselves only with PCA. Remember that. Okay. Let me ask another question. What are the properties of principal components? Properties of principal components. Yep. Mm-hmm. Low correlated or more variance, highly perpendicular. Properties, guys, properties. We're talking about properties. Correlation, orthogonal transformation. Okay. Okay, let me tell you. The properties of principal components are that the correlations, the variance of these principal components will always be in decreasing order. Right? These correlation, the variance in PCs is captured by maximizing the variance at each PC. We try to maximize it, right? So we get highest variance captured in the first principal component, followed by the second one, followed by the third one, followed by the fourth one, so on and so forth. So the variance is in decreasing order. Then if you look at any two pair of principal components, they always are perpendicular to each other. That means the correlation among them are zero. Right? The correlation between them is zero. Next. These principal components are captured in such a way that you get the equal size of dimensions as of your original data set. So if you have n original columns, then your principal components will also be equal to n original columns. Right? 6 original columns. Remember, in our sessions, we discussed about 6 original columns and we get 6 principal component weights. 6 by 6. Yep. So that's the basically the properties of your principal components. Now, let's talk about another question. Okay, what is the equation of SVD? Let's see how many of you answer. Okay, 2, very good. Wonderful. So SVD is singular value decomposition, and the formula of SVD technique is X is equal to U diagonal V transpose, where D is a diagonal matrix, U and V are orthonormal matrices. Orthonormal means they are perpendicular to each other, and orthogonal. But that means perpendicular, and when you take the squared values of the columns of each of this matrix and sum them, it will be equal to a unit vector. You will get 1. So these are the properties of your matrices. SVD deals with this equation. Very good. Next. What is the difference between PCA and clustering? This is also something you know. Difference between PCA and clustering. Yeah. Very good. Clustering is creating groups based on number of rows you have, right? So clustering is creating homogeneity in your data by grouping similar records. In PCA, we are dealing with the columns, the features. Right? We try to capture the similarities in the, or homogeneity in the columns. Right? TCA and clustering. That is the primary difference that we need to remember. Next. How do I create, let's say, how do I define relation between two entities? Yes. Okay, I'm talking about entities, not talking about variables. Okay. Union and interception, okay. Oh God, okay. Wonderful. Okay. So we are talking about entities. We are looking at the relation between two entities. Right? Now, when you say entities here, we are talking about let's say, products. Relationship mining, guys, market basket analysis is what I'm talking about. The relationships can be interpreted by probabilities only here also. In relationship mining as well, we are looking at probabilities, how strongly two entities are related. Right? I can speak about probability only. And this relation between entities can be explained using market basket analysis or association rules, which use probability. Okay, so let's look into the next question. Okay, give me a minute. Yeah, I should be back now. All right. What is the default data type for performing association rules? What will be the default data type or data structure, I should say, that we collect for performing association rules? Yeah. Matrix data, okay, but that's not the default. Transactional data, very good. Suresh, very good. List. So the data structure we are talking about, each record is a list of items. So, right, so we will have transactional data, which is also known as list here. In R programming, we specifically call it as transactional data, whereas in Python, we deal with a list of variables. Very good. What is the drawback? What is the challenge in performing relationship mining, association rule mining? Okay, let's see. Okay, profusion of rules. Not really, that's not the challenge. Not really, not really. No. Many parameters, okay. The primary challenge in performing association rule mining is the number of rules that we are generating. The number of pairs, combinations will be very huge. Exponentially grows when you have n distinct item catalog. Right? The combinations that we can create will be huge. What are the rules in association rule mining called as? What are these rules called as? Yeah. No. Very good, Rakesh. These are called as probabilistic if-then statements. Association rules are nothing but if and then statements. But we select only those rules which have high high probability. Probabilistic if-then statements. How do we measure this probabilistic if-then statements? We have to quantify. How do we quantify? Very good. We have three different measures: support, confidence, and lift. What does support means? What does support measure? Yeah. Minimum count, it simply calculates frequencies, guys. It captures frequency. Very good. Support is nothing but frequency. Yeah. And this frequency is represented as probability. It is represented as probability. Yep. And that formula is the number of times the if part and then part appear together by total transactions. How many times the pair of items appearing in the transactions? What are the drawbacks of support based rules? What are the drawbacks of support? It does not capture the dependency. It will not capture dependency. Very good. Yes. Wonderful. In order to capture the dependency, what measure we use? Confidence. Very good. Okay. What is confidence based off? What is the confidence formula based out of? The logic. I'm talking about the logic of confidence. Confidence. Conditional probability. Very good. It is based on conditional probability. Very good. What is the drawback of confidence? What is the drawback of confidence? It does not capture the true difference. No, it is based on dependency only, right? Biased, yes. The drawback of confidence is that it does not capture independency. Right? In support, we are only looking at the count, the frequency. But individual, independent products will not be able to interpret the relationship. Hence, we go with confidence. But the drawback of the confidence is that it is not able to capture the independency between the products. It is only capturing dependency, right? It is not capturing independency. So in order to overcome this biased dependency calculation, which is your confidence, what needs to be done? What can we do in order to capture independency as well? We assume that the products are independent. What is benchmark confidence? What is benchmark confidence? Yeah. $95? No. No. We're talking about lift here, lift calculation. No. Independent, yeah. G1 is right. Yes. That's right. So we are basically taking, or we are assuming that the antecedent and consequent items are independent of each other. And then we measure probability. Confidence is also probability measure, but in confidence, we are assuming that the products are dependent of each other. Right? Whereas here, we are treating, in benchmark confidence, we are treating that the data is independent of each other. These two events are independent of each other. Right? So that's the difference. What is the threshold lift value? What is the threshold lift value? Not -1. 1 is the threshold. We want values which are greater than 1. Very good. How do we interpret lift ratio 1? Yeah. Confidence by benchmark confidence is lift calculation. Very good. But what does these rules which give lift ratio greater than 1 mean or less than 1 mean? Very good, Lokesh. Lift ratio less than 1 means the association between the two, antecedent and consequent, is less. If it is greater than 1, that means association is more. Lift is interpreted as dependency by independency, right? Now, if it is greater than 1, that means dependency is more. If it is less than 1, that means independency is more. Right? Okay. Next. What is the drawback of lift? Yeah. Let's see. What is the drawback of lift? Profusion of rules, yes, duplication of the rules. That's one of the drawbacks of lift. Very good. Yes. So the problem with the lift is it just takes the ratio between two products, right? Ratio of dependency between two products, dependency versus independency, right? And when we are trying to see antecedent and consequent can be replaced, the positions can be replaced. Combinations we are checking, right? So the bundle offers that you look at, when you say bundle offers or bundle of the products, then these bundle will have same products irrespective of what is their position. But lift ratio will be different for these combinations of the same products. So you'll get duplication of the rules. And these duplication of the rules happen with different lift ratios. Yep, so that's the drawback of lift. And another problem with lift is, unless until we know what is the count of, or what is the data which is related to consequent item, we will not be able to measure lift. We need to know full details of consequent item. Only then we will be able to calculate lift. Right. Yeah, so somebody was looking for a break. We are going to take the break now, and we'll follow up with a lot of additional questions after the break. We'll continue. So it's 11:33 now. We'll take a 7-minute break. We'll come back at 11:40. All right? Okay. I hope you are able to hear me now. Yeah, sorry, I was not on. I was on mute. Yeah, my bad. So we're talking about unsupervised learning techniques, right? So we discussed about clustering. We discussed about dimension reduction, right? Here we talked about PCA, SVD. We also talked about LDA. Then we have factor analysis, right? And then we move to discuss association rules, which is also known as market basket analysis, affinity analysis, or relationship mining, right? And here we talked about 3 measures: support, confidence, and lift. Where the lift has a threshold, we try to understand about the threshold. Which basically is 1. Threshold is 1. Now let's talk about personalized strategy. Recommendation engine is also known as collaborative filtering. What are the distance measures used for calculating similarities? What are the various distance techniques that we apply for measuring similarities between the entities in collaborative filtering? Cosine based, Euclidean Manhattan, any distance technique can be applied. Very good. We can apply any distance technique. Very good. What are the drawbacks of customer to customer based collaborative filtering. Yeah. Drawbacks of collaborative filtering. Lazy learning, very good. We have lazy learning problem. The computation will start only after we know what is the customer, who is the customer. Very good. Yes. So computationally, it becomes very expensive. Next, how can you differentiate collaborative filtering with association rules? Yeah. Generalized, personalized, okay. That's it. Yeah, personalized filtering is already mentioned. In collaborative filtering, we do not require data, prior data. It's not mandatory to have historical data for collaborative filtering, for generating recommendations. Whereas for association rules, historical data is must. That's another difference. Right. What are the different collaborative filtering strategies that we can apply? Yeah. Mm-hmm. User based, item based, okay. Keyword search based, attribute based, very good. We also have SVD based techniques. Yeah. But what strategies can I apply to come up with recommendations for similar customers? I have identified similar customers. Now, what strategies can I apply for doing the recommendations? What can I recommend? Rating, okay. Rank, okay. Not really. We're talking about customers. Similar customers are already identified, Ajma. Very good. Highest rated. That's already there. Excuse me. Okay. So the strategies can be anything. One of the strategy is what are those products which the similar customers have purchased already, but our customer has not purchased. And these recommendations will see the list of items based on certain conditions. We'll rank the similar customers purchased items based on certain conditions. One of the conditions that we look at here is the rating, maximum rating for the products. The other conditions we can look at is the number of similar customers purchasing the product. Or you can also come up with different strategies completely on these list of items. But one important point we need to put here is do not make the list of items, or you do not count the item which is already purchased by the customer for whom we are trying to recommend. Right? So make the list of items, shortlist the list of items which your customer might purchase. Right? That means all these items are already purchased by similar customers like this customer X. And then we rank them. How do we rank them? That depends on your strategy. One of the strategy could be rankings. One of the strategy could be the quantity. One of the strategy could be the profit margin. Right? Demographical relevant conditions could be there. So you can apply any of these different strategies that you can think of and rank them. And based on the ranks, you might want to choose top few ranked items to recommendation. Okay. Next. What is let me think of, okay, my question is okay, what is a connection between two nodes is called as? Yeah, only few people answering. Edge is the right answer. We are talking about edge. Very good. So we have connection between two nodes is called as an edge, and the nodes themselves are called as vertices. Right? So we'll have edge matrix. Now, strength of a network can be measured using what techniques? What all techniques can you think of? Very good. Degree centrality. Centrality measures, okay. There are different types of centrality measures, isn't there? Page ranking, closeness, centrality, betweenness, centrality, very good. So we are looking at centrality. Betweenness, centrality would be there, degree centrality would be there, right? Closeness, centrality. So centrality measures are being used for measuring the strength of the network. What is in degree? What is in degree centrality? Explain. Okay. Sai Krishna is correct. Lokesh is correct. Anuj, very good. So in degree means the number of connections that are coming inwards. Right? That's called as in degree centrality. Okay. Next. Betweenness centrality. What is betweenness centrality? Very good. Betweenness centrality is a measure which represents the node being in the center of the network. As the name suggests, it's betweenness centrality. So the node has more value if it is being at the center of all the connections. Right. What is the drawback of degree centrality? Drawback of degree centrality. Drawback of degree centrality. Very good. Degree centrality captures only the direct connections. It is also known as only a local measure. It does not talk about the overall connections that impact the value of a node. Very good. So that's the drawback of degree centrality. Next. Let's move on and talk about the difference between supervised and unsupervised learning techniques. Yeah, all this while we were talking about unsupervised learning. What is the difference between supervised and unsupervised learning technique? We have already discussed this at the start of the session today. Very good. From the historical data, we know what is output variable. Right? Simple. If you know what is the variable of interest that you are trying to predict, then it is supervised. If you do not have any specific variable of interest, then it is called as unsupervised technique. Wonderful. Next, when we talk about supervised learning, what are the variations of these supervised learning techniques? In supervised learning techniques, I'm talking about the variations. Yeah. Okay. No. Yeah, that's right, Jivan. The variations are regression techniques and classification techniques. Your label data, the output that you're trying to predict, is either numeric data or non-numeric data. For numeric data, you apply regression methods. For non-numeric data, you apply classification techniques. What is the difference, or what is the, or I should say, when do we go with supervised learning techniques and when we go with unsupervised learning techniques? Well, what is the, I should say, necessity? When can I go with unsupervised learning techniques? And when can I go with supervised learning techniques? Yeah. Very good. So when we want to do predictions, we are talking about output variable being known in this case, right? From the historical data, we know what is the variable of interest. Right? Yeah, am I audible now? Yeah. So I was briefly gone for that. Okay. So we apply supervised learning techniques when we have to do predictions, because we know what is the variable of interest. Right? And we apply unsupervised learning techniques when we have variable not known, variable of interest not known. So here we are trying to do descriptive analytics, right? So that's the difference. That's the approaches that we take for data mining. Next, how do we evaluate these techniques? Very good. Okay. Okay. So we evaluate the models by measuring the accuracy or the performance of that particular model on test data. So for supervised learning techniques, we need to apply data partition. Do I require to partition the data for training purpose for unsupervised learning? It is not mandatory, right? It is not mandatory. Now, what should be the strategies? What should be the strategies applied for data partitioning? Yeah, what should be the strategies that should be applied for data partitioning? Okay. Yeah, Jivan. So we are basically a relevant answer, sample records, sampling, stratified partitioning. Okay. Oh God. Okay. So many different answers. Very good. Very good. So when I say data partitioning, we are splitting the data into train and test, right? So one of the strategy, the key strategy that we need to remember is the training data should be either greater than or maximum, or I should say minimum, equal to the size of test data. Training data should be large. That is the key point that we need to remember. Now, if your output or your variable of interest, if that is numeric in nature and if it is continuous in nature, then we apply random partitioning. We apply random partitioning. But what if your data is categorical in nature or discrete in nature? What strategy should I apply for partitioning the data if the data is categorical? Very good. Stratified sampling. Why? In order to get generalized error, generalization error, we need to verify the model to be working on the historical data that we are getting. And if you have categories of output variable, if your output variable y is categorical, then to make sure we reflect this data into training and test, we take the proportion of the categories, right? And these proportion of categories should be identical in train and test with respect to the population data or historical data here, right? Hence we apply stratified sampling. So these are the strategies that we apply for data partition. Next, what is bias? And what is variance? Bias means, bias basically means underfitting. But how do I interpret it? Bias basically means the error that you are getting, right? The error that you are getting while you're training on your model. You're not able to train the model properly, right? So that's bias. Variance means overfitting. You can interpret it as overfitting. So your training is overdone, right? So that's the bias and variance trade-off. So we always try to get high variance. We always try to address bias on the training data. But when you're trying to address bias, you might go for high variance. So to balance this, we use train test data partitioning technique, and we evaluate the overfitting and underfitting cases. Yeah. Very good. Next question. Okay. How can I address variance or overfitting? How can I address overfitting? Very good. By applying regularization techniques. Can you name regularization techniques? Very good. Lasso rich. What else? What does these regularization techniques do? What does these regularization techniques do? Okay. Exactly. They are going to attack, or they are going to address the high variance problem, overfitting problem, by removing the unwanted features. So they are basically helping out with feature selection. Backward feature elimination, forward feature selection. So feature selection techniques can also be applied for addressing the overfitting case. How do we calculate generalization error? Yeah. No. Generalization error. Bias plus variance plus. What does generalization error means? Of course, error means predicted value minus actual value, or actual minus value predicted value. Very good. Generalization error means the error that we are encountering on test data. That's called as generalization error. So generalization error we calculate based on the test data. Remember that. Formula is same. You do actual value minus predicted value only. You calculate RMSE only. But it is on tested data. You have to specifically mention that. Right. What are the properties of error? Very good. Errors should be following IID normal properties. That means they should be normally distributed. Errors should be normally distributed. And the errors should be statistically independent of each other. And errors should also be identical, similar to each other. Right? That's what IID means. Another property of error, very important property of error, is sum or mean of error for any machine learning algorithm will be equal to 0. Only then we call it as a unbiased technique. Only then we call it as unbiased method. Now, to measure a quantified error, we use What techniques? What can we do for measuring errors? What all error techniques are there? Error functions. We have MAD, mean absolute deviation. We have MSE, mean square error. RMSE, root mean square error. Right? Mean absolute percentage error or mean percentage error. Right? Mean absolute percentage error or mean percentage error basically give us the error in percentage form, unit free. Right. Next. How do we measure? What measures are used for model evaluation of classification techniques? Very good. Very good. To measure the model evaluation, to perform model evaluation of a classification techniques, we use confusion matrix because we cannot perform difference on non-numeric data. So we use comparison approach, and here when we are doing comparison, we apply confusion matrix. And as part of the confusion matrix, we get overall error, we get overall accuracy, we also get precision, we also get sensitivity, we also get specificity, we also get F1 ratio, right? And we'll try to interpret the accuracies of the models by considering all these factors. That's how we evaluate a model which is performing predictions on non-numeric data. What are these techniques also called as? What are these measures also called as? We talked about cross table, we could talk about confusion matrix, right? What are those also known as? Different names. Error functions. Cross entropy or binary cross entropy. Cross entropy is nothing but cross table. Binary cross entropy is nothing but confusion matrix. Next. What is sensitivity? Yeah. Okay. Explain. Suresh, no. Okay. Sensitivity is basically a measure which talks about how many times the true event was correctly identified or predicted as true event. Right? So we need to get true event correctly being identified as true event. That is sensitivity. Got it? Yeah. Precision is a different calculation. Precision is basically saying how many of the true events were correctly identified as true events when you are randomly saying everything is true. Yes. Right. Next. There's a condition for considering the accuracies of your confusion matrix. What is that condition for considering the accuracy? What is the minimum accuracy that should be considered for a classification method? What is the minimum accuracy that we should consider, that should be considered for a classification method? No. Okay. The minimum percentage of accuracy that we need to consider is yeah. Okay. So when you talk about classification techniques, we have different categories, right? We're talking about different categories. If I take confusion matrix, then we are talking about a binary category scenario. We're not talking about cross entropy, we're talking about binary cross entropy, confusion matrix. So I'll have either 1 or 0. So the minimum accuracy should be greater than the majority class. 1 class, 0 class. Right? These could be imbalanced. So the accuracy that we are considering should be greater than the majority class. Yeah, that is a condition. Minimum, right? Minimum accuracy condition. All right, next. What is the full form of ROC curve? Okay. Receiver operating characteristic. Very good. What does it tell us? Why is it used? Mhm. Very good. ROC curve is used to decide the appropriate cutoff value. ROC curve is a visualization technique. It's a plot which gives us the curves representing the values of true positive rates versus false positive rates. It's taking the trade-off between true positives and false positives. We want true positive. That means a false negative should be 0. We need to have high true positive rate, 100%. When you're trying to do, you're saying everything is positive. But if you try to do that, your false positives might increase, right? So we need to have less false positives. Ideally, it should be 0. So the trade-off between sensitivity, which is true positive values, true positive rate, versus false positive rates are plotted. And this tells us what is that ideal cutoff which gives us good accuracies. Right. Next. How do we do? Okay, what are the assumptions? What are the conditions of errors? I have already asked, right? Okay. What are the steps taken to handle imbalanced data? What we do when your data is imbalanced? Very good. There are two ways to handle imbalanced data cases. Whenever we are dealing with any model, to tune the model for better accuracies, there are two techniques, two approaches. First approach is to handle the data. You manage with data. And the second approach is to manage with the models itself. Now here we are talking about imbalanced data. So that means data has some challenges. So we use oversampling, undersampling, right? Intelligent sampling techniques to make sure there is some kind of balance established in the sample data. Right? Different sampling techniques can be applied here to manage the balance in the imbalanced data. Right? And we can also apply ensemble techniques to handle imbalanced data. Right? To improve the accuracies on the imbalanced data, we can also apply ensemble techniques. Next. How do I do classification? Okay. Let me ask this. What is the tuning parameter in KNN classifier. K is a tuning parameter, right? Easy question. Very good, yeah. K itself is a tuning parameter in KNN. What is another name given for KNN algorithm? Lazy learner, very good. We call it as lazy learner. Okay. Okay. In KNN technique, what if I have same distances from two different categories when I am applying a certain K value for classification? Yeah. We are going by shortest distance technique, right? What if I have two different categories having same distances with respect to the new category, new record? How do I classify? I'm talking about same distance. No. Choose odd number of K. Okay, that is a workaround. Okay, very good. Arbitrarily, it chooses one value. There is no logic there. Right? These KNN algorithm is a shallow algorithm technique which is based on distance. Right? And if distance is same, arbitrarily it picks one of the categories. And anyways, we have tuning parameter in terms of K to get a better result for, right, different K value. So we alter K value simply. But for a given K, if you have the same distances, then it is randomly choosing one. There's no logic there. Okay? All right. Next. For any techniques, right? For any algorithms that you are developing in machine learning, if I have different scales of your variables, input variables, what would be the result? What would happen? Yes, it impacts the prediction results. Yes, and we are biasing the model by giving more importance to the variables which have high magnitude. The models are getting biased. Very good, yes. What is the distance measure that is applied in KNN? By default, Euclidean. Right? By default, it applies Euclidean distance. It can apply, we can choose any distance metric But by default, the distance measured is Euclidean distance. Very good. Okay, what is a p-value in statistical analysis? What does p-value means? Probabilistic value measure of measuring coefficients, probability values. Yeah, but how do I interpret? P-value is nothing but probability value, but how do we interpret it? Very good. It's known as significant value. Wonderful. Ideally, it should be less than 0.05. But how do you interpret this? Okay. So p-value is, which is also known as significant value, is basically a strength of your prediction. Right? What we are doing basically is we are trying to estimate a result. Right? Now, when you're trying to estimate the result, what is the chance of you going wrong in estimating? That is what p-value is all about. It is a measure, it is the chance of going wrong. Yeah, that's your p-value, which is known as significance level or significance value. Next. In classification techniques, okay, what is Bayes' theorem? Yes, it's based on conditional probability. Very good. Bayes' theorem is nothing but conditional probability, right? It speaks about the chance of an event, the probability of an event, occurrence of an event, based on another event which is affecting this second event. Conditional probability, what will be the output of an event based on a condition? Yeah, it's called as conditional probability. Now, can you tell me what is class prior? What does class prior mean? Okay. Class prior means the probability of the class in the historical data. You already have historical data where the events are already occurring, right? You have recorded these events. When you look into this historical data, you'll come to know what is the chance of a specific class. That's known as class prior. What is posterior probability? Posterior probability is nothing but conditional probability. Exactly. Probability of a class given condition. That's your posterior probability. What does data likelihood or class likelihood given data means? Or I should say data likelihood. Data prior is basically the probability of data in your historical data, but what does class likelihood given data? Very good. Class likelihood given data means, or data likelihood basically means, what is the chance of data or what is the chance of the condition for a given class. So your Bayesian theorem, your Bayes theorem that we are talking about, has all these terminologies, right? Your conditional probability is based on these problems only, right? This theorem only. So if you say probability of B given A, you know that condition A has already occurred. Then you are going to say probability of A given B multiplied by probability of B, right? Whole divided by probability of A. So what is the class? You're basically saying what is the probability of the class given the condition. So you're first checking what is the class, probability of class in the historical data. Then what is the probability of this condition arising in this class under what the probability of the conditions, overall condition. So this is your Bayes theorem. Next. Let me think of some question here. What am I forgetting? Okay, what is the tuning parameter in Bayesian classifier? Very good. Laplace technique, right? Very good. Okay. What is basically required for improving your model's accuracy? The basic requirement for improving your model's accuracy. Any model. Very good. Data. Wonderful, Ram. So you need data. If you have more data, your machine can learn better on the patterns and hence it can predict better. Okay. Next. We talked about overfitting, underfitting scenarios, and right, we also want to consider a right fit. Right? Now, when do we call a model is overfit? How high is high? Very high. Okay. Okay. So overfit is a condition when you get training error very less compared to test error. Right? That means the accuracy of the model, the prediction of the training data is very well done by the model. But when we are using a new data, that is test data, the accuracies are very low. High error is coming up. But can we quantify this? Yeah, can we quantify this? Okay, so the answer is subjective. It is not fixed. Though the rule of thumb says somewhere around 3% to 5% of the difference is ideal to call a model as right fit. That means the error difference between training error and the test error should not be beyond 5%, 3% to 5%, not be beyond that. If it is beyond that, then we consider it as overfit, and only this is a thumb rule. It is not applicable for all the cases. Okay? It's only a thumb rule. All right. Okay, when okay, let's think of one more question. How do you measure? Okay, what metric we use to decide on model's accuracy for regression? Yeah. Okay. Very good. Error only. RMSE are made. Error calculations are used to evaluate the accuracies of the model. Then what does R squared means in for regression? What parameter does or what metric does R squared actually explain? Goodness of fit. Okay, the name is coefficient of determination, right? Okay, SSR by SSC, okay. R squared, very good. Yes, it's capturing the proportion of variance. That's nothing but SSR by SSC, right? So R squared is capturing the effect of the changes in Y that are caused by the changes in X. So you can say overall correlation parameter is R squared. Goodness of fit is the another name given for R squared. It is also known as predictability measure. So how well can I predict the variations in Y given the set of input variables? Right? So that's your R squared. Now, what is the difference? Okay, we'll talk about that in detail tomorrow. All right. So I'm not sure how many questions we have recorded. So we will have session again tomorrow. Right? Okay, one more question. Yeah, we need to talk about this. How do you evaluate an unsupervised learning technique output? Now we discussed about a lot of things with respect to supervised learning techniques. So you tell me, how do we evaluate an unsupervised learning technique, guys? Yeah. For example, clustering. What techniques we'll apply for clustering? Labels, very good. Homogeneity, right? If you are able to successfully label the clusters, then clustering exercise is a success. If I talk about recommendation engine, if customers, when you are doing personalized strategies, if your customers are choosing the results or choosing or taking decisions based on the recommendations that you're making, then your recommendation engine or recommendations is success. Right? So evaluation of unsupervised learning techniques are interpreted by subject matter experts. There is no quantifiable techniques to measure the unsupervised learning techniques output. Yeah? So we will have to take subjective decision based on the inputs from subject matter experts. All right. So this is for today. Tomorrow we will continue on further discussions with respect to the interview preparations. There are thousands and thousands of interview questions can be discussed, right? So yeah, we're randomly asking questions and talking about that. So today I tried to cover unsupervised learning techniques as well as some of the classification techniques. All right? Yeah. So please join us tomorrow. Join me tomorrow and we will discuss further more questions. We'll also have to look into R and Python questions, right? So yeah. Stay tuned, guys. Let's connect tomorrow. Thank you all. Thank you.